Hi, class. It's Dr. Lindner. Welcome. And what we're going to be covering in uh, these next few videos is the circulatory system, primarily focusing on the heart or cardiology. So the heart is a four-chambered muscular pump. And simply put, right, if I were to draw something like this, and of course the heart does not look anything like this, but we can all kind of remember this nice and easy. Top chambers are going to be atrium, and bottom chambers are going to be ventricles. When I talk about the heart, everything on this side is right, everything on this side is left because we are looking at an individual, right? So their right arm and right shoulder would be here, their left arm and left shoulder would be here, and so forth. So we would call this the right atrium, the left atrium, the right ventricle, and left ventricle. Okay, so it's a four chamber muscular pump. And I'm going to draw it out again in a little bit, and I'm going to divide it from a functional perspective into the right chamber and left chambers, right? So I'll talk about the right side being pulmonary because it pumps blood to the lungs. And then I'll refer to the left side as systemic because it's pumping it to all the systems of the body. So the heart is about the size of your fist, and the location of it, it is superior to the surface of the diaphragm. It's slightly to the left of the midline. It is in front of the vertebral column, but it's behind or posterior to the sternum. And that exact location is what we refer to as the mediastinum. Okay, it's this description, and it's also between the two lungs in the thoracic cavity. So here we have the two lungs. We see the right lung. We have a upper, middle, and lower lobe. On the left side, only an upper and lower lobe, or superior and inferior, and middle, superior and inferior on the left. You can see the heart pretty much in the center here, with all the blood vessels coming up. And we'll go through some of these main blood vessels. You can see the diaphragm down here. So I really like this picture because this picture, if we really take a close look at it, explains to us a few things. Now, one of the things I want to point out, we already know that the top chambers are atrium, the bottom chambers are ventricles. We know that. What I want to point out is if you look at the right side, which is our reading left, right? But this is the right side of the heart, right atrium, right ventricle. Notice that everything here is the color blue, and that everything on the left side, left atrium, left ventricle, notice is red. This is an important concept from a functional perspective because what is coming into the right atrium, up to the right atrium and the right ventricle and pumping up into this structure called the pulmonary trunk, which leads into the pulmonary arteries, is all blue because this is carrying deoxygenated blood. Deoxygenated, right? You hear oxygenated. Deoxygenated means there's no oxygen. So it's deoxygenated. And what happens to an individual if, we hear about these horror stories all the time where an infant or a baby falls in a pool, they drown, they pull the baby out, and the lips are blue. Why? There was no oxygen, right? So deoxygenated is blue, oxygenated is red. Okay, so keep that in mind. So we have deoxygenated blood coming into this vessel right here. That vessel, this large blue one, is called the superior vena cava. And you could abbreviate for now if you're taking notes, SVC, superior vena cava. And if there's a superior vena cava, there's going to be an inferior vena cava, an IVC. So the superior vena cava is bringing all this deoxygenated blood from everywhere up here, which is like the head and maybe the arms, right and left arm. It's going to bring all of that deoxygenated blood into the right atrium, and everything from the lower part, including like the abdomen, your hips, your legs, your feet, it's going to bring all the deoxygenated blood back into this right atrium. And then from the right atrium, blood's going to flow into the right ventricle, and it's deoxygenated. And then the ventricle is going to contract and push this deoxygenated blood. We see the arrow up here into this pulmonary trunk, this tree trunk, this pulmonary trunk. And from the pulmonary trunk, it's going to go into the left and the right pulmonary artery. And when it brings it into the left and right pulmonary artery, it's bringing this deoxygenated blood into the heart. Into the lungs, where it's picking up oxygen. Now, after it picks up oxygen in the lungs, it needs to find a way to get that oxygenated blood back into the heart. And now the oxygenated blood is going to find its way into the pulmonary veins. The pulmonary veins on both left and right side. Now, this oxygenated blood goes from the lungs into the left atrium. Now we see it's red. It's red in that left atrium because it's oxygenated. Then the oxygenated blood flows into the left ventricle. And I'm going to go through this all again. And then the left ventricle is going to pump blood up in this direction through this aorta. And you see it's red because it's oxygenated. And then we see 1, 2, we see these 3 main blood vessels coming off the arch of the aorta. These 3 blood vessels, from these main blood vessels, they're going to bring blood to the head and the right and left arms. Oxygenated blood, just from these 3. Okay, so that's a general overview, and now we can look at it the same thing here on this page, and now it's numbered. So it's somewhat easy to follow. But I'd like for you to look at number 10 right here. We'll start here, and number 10 right here. So we're looking at the superior vena cava and the inferior vena cava. And you can see the key down here on the lower left, deoxygenated blood, right? Oxygen poor blood, no oxygen, deoxygenated. So all the deoxygenated blood is now going to pump into number 1, which is your number 1, look to the right here, right atrium, deoxygenated blood. From number 1, the atriums are going to push the blood down into the right ventricle. And you have some valves here, and I'll go over what the names of these valves are shortly. But for now, just want you to get the name of the concept here. Well, I might as well name it. This is the tricuspid valve, TRI. We'll put TRI for tricuspid. Tricuspid valve is right here on the right side. So the tricuspid valve is open, blood is going to come down, and let me change it into let's change it into blue because it's deoxygenated. So the blood is going to fill up into this ventricle, into that right ventricle. When it fills up and the pressure builds up so great, these ventricles are going to contract. And when they contract from inferior to superior. They push up this way, from inferior to superior, when the ventricles contract. When the atriums contract from superior to inferior, which makes sense, right? So it's going to push the blood down. But when the ventricles contract, they contract inferior to superior. And when the pressure pushes up, it closes the tricuspid valve. This valve then shuts, and it diverts blood up here where this is like a push door. This is like a push valve. It pushes that right open, and that's called the pulmonary semilunar valve. This is the pulmonary semilunar valve. So as blood is exiting the left ventricle, it has to push through this pulmonary semilunar. Now it's in this pulmonary trunk, and from the pulmonary trunk, it's going into the left and right pulmonary arteries. Yes, these arteries are blue, right? They're color-coded blue because they are deoxygenated. Arteries are traveling away from the heart. Veins are bringing blood back to the heart. So now we have this deoxygenated blood that is now in the lungs, and now from the lungs, there's this exchange, right? The pulmonary capillary to the left lung. You have this exchange, and oxygen is now going to find its way into number 5, right here and right here. These are the pulmonary veins. And now the blood is oxygenated. I'm going to make this black here. So now it's oxygenated, and we have blood coming into the left atrium. It'll move down into the left ventricle, and it's got to go through the mitral valve. This is I'll put an M here for mitral, or I'll put a B here for bicuspid. On the right side, you have the tricuspid. On the left, you have the bicuspid, aka mitral valve. So the left atrium pushes blood down into the left ventricle. And again, when the left ventricle starts to pool and fill with blood, and the pressure builds up and builds up and builds up, the ventricles contract inferior to superior once again, and the blood pushing up shuts the mitral valve, but it pushes, you can see this arrow here that's heading into the aorta, it pushes the aortic semilunar valve open. It pushes the aortic semilunar valve open. Blood continues in this direction. It's all oxygenated. And now it's going to go up number 1, number 2, number 3. These vessels are going to lead into the head and both arms. This one here on the right side is called the brachiocephalic. We'll put a B, C here, brachiocephalic. This one, number 2, and I'm going to put a line here. We're going to divide this. So this side is right, and this side is left. So right here at this bifurcation, it splits. This is the left common carotid, left common carotid. And number 3 is the left subclavian artery. Okay, subclavian under the clavicle, left common carotid, it's going to go up the neck, and brachiocephalic, brachio means arm, cephalic means head. So on the right side, you only have one blood vessel that's going to lead to the head and arm, but on the left-hand side, we have 2 separate ones, one going to the head, one going to the arm. Pretty neat how the body does that. And then this arch of the aorta kind of descends, it comes down, and then we can see it right here at the bottom, right there, and that's going to lead into the abdominal region, the abdominal aorta. And it's going to bring oxygen to all the organs of the abdominal region. And then it's going to go and split and go into the right and left thighs and bring oxygenated blood there. Okay, so I'm going to draw this out one more time because I really want you to understand it. You'll all have access to this PowerPoint, of course, and there is a link that leads to my YouTube channel. This is an old video. I'm going to say it's probably 10 or 12 years old, but the content is great. It really is, and it's me going over the flow. So I'm going to try and do it again here for you so you can see it without see it in action. Okay, so let me change this color here back to blue. So here's the right side and here's the left side, and I'm going to put a blood vessel here right? We're going to call that the superior vena cava. Okay, I'll put that number 1, superior vena cava, and that's leading into, we'll call this number, hold on, let's do another one down here. Again, this is not to scale, of course. This is just for simplicity to help you understand. Number 2 is the inferior vena cava. So both superior and inferior vena cava are going to bring deoxygenated blood into number 3, which is the right atrium. When the blood pools in here, and there is one more entrance, I might as well draw it in here. So there's one more entrance for a blood vessel to come into the right atrium, and we'll call that number 4, why not? Number 4 is called the coronary sinus. So number 4 is the coronary sinus. The coronary sinus is going to bring deoxygenated blood from the actual heart muscle itself. Okay, there are arteries and veins that go to the heart as well. So there's oxygen that needs to be going to the heart muscles, and then it becomes deoxygenated. It's got to find a way back into the right atrium. All right, so number 4 is the coronary sinus. All right, so now blood is pooling up into this right atrium. And when the pressure builds up and builds up and builds up, this valve opens. We'll call that number 5. Valve number 5, we know that's the tricuspid valve. Tricuspid valve. So when the pressure builds up, that opens, and now we have blood that's now entering into the right ventricle. And this blood is going to pool up, pool up, pool up. Now, when the atrium contracted, it pushed blood superior to inferior. When the ventricles contract, they push blood inferior to superior. So as this blood pressure in here is building up, and it pushes upward, it's going to shut this AV valve. We have AV valves, which stand for atrioventricular valves. That would be this and this. These are the 2 valves between the atrium and the ventricle. So it's the atrioventricular valve, but the one on the right side is called the tricuspid, and the one on the left is the bicuspid, aka mitral valve. So this one's on the right, bicuspid is on the left. The other name for bicuspid is mitral valve. Okay, let me change this color for a second to black. Now, right here, this is a major opening to a blood vessel. And now let me make this blue. Make it a little lighter blue here. So this is going to come up, follow me here, and then it's going to go this way, and this one is going to go this way, and let's say that's a lung, and then here's the other lung. Okay, so as blood in that right ventricle, the pressure builds up, it's going to push upward, and as it pushes up, it's going to shut the tricuspid valve. That shuts, but this one opens. This opens. So why don't we call this number 6? Okay, and number 6 is the pulmonary semilunar. So we have AV valves, and then we have semilunar valves. Semilunar. Semilunar. And the semilunar, there's also 2 of them. This is the pulmonary semilunar. Pulmonary, which means lungs. We know it's going to go to the lungs. So there's a pulmonary semilunar. And then there's an aortic semilunar. All right, so number 6, Blood is pushing up, forces that pulmonary semilunar open. We have deoxygenated blood coming up, going this way, and deoxygenated blood coming up, going this way. Okay, now number 6 was the pulmonary semilunar. Now we have number 7, pulmonary trunk, leading into number 8. We will call that the pulmonary arteries. Pulmonary artery, pulmonary artery. Arteries pump blood away from the heart. This is the left pulmonary artery. This is the right pulmonary artery. Okay, so again, the right ventricle contracts, pushes blood upward as it pushes up. The tricuspid valve closes. The pulmonary semilunar opens. Deoxygenated blood is flowing through the pulmonary trunk into the left and right pulmonary arteries. That deoxygenated blood makes it into the lung. Both sides. Makes it into the lung. Now there's capillary exchange here. And now we are going to have the blood being oxygenated. So the oxygenated blood is going to find its way okay, you're following me here? A little crude drawing, but hopefully it makes my point. So now the oxygenated blood is going to find its way in here from the lung. And again, oxygenated blood coming this way. These vessels, this is called the left pulmonary vein. The other would be the right pulmonary vein. Let's call that's 8. Let's call the 9 will be the lungs where the exchange takes place. Then we'll say 10 on both sides are the pulmonary veins. So the oxygenated blood is now pooling. Now I'm using red, so it's pooling up in the left atrium. And the left atrium contracts a little bit, just like the right atrium, plus gravity is going to bring the oxygenated blood here into the left ventricle. Okay, it had to go through the pressure in that left atrium built up a little bit, and it forced the mitral valve. The mitral valve is also the bicuspid, so we'll put mitral here. Mitral is the same thing as bicuspid. So from the left atrium into the left ventricle through that mitral valve. And again, as the pressure in that left ventricle builds and builds and builds, remember, ventricles contract inferior to superior. So when that force of blood is pushed upward, it's going to shut the mitral valve. But there is another valve right here. Okay. Now that is the other semilunar called the aortic semilunar. And I'm going to make it red because it's got oxygenated blood. So when the left ventricle pushes blood through, we'll call that, let's see, hold on. The lungs was here, that was 10. So let's say 11. We'll call 11 is going to be the left atrium. And then let's say 12 will be the mitral valve. We'll say 13 is the left ventricle. And now blood is pushing up, pushing up. It pushes through number 14, the aortic semilunar. And now we have blood coming up like this. Here's the blood vessel coming up like this. And then we have 1, 2, 3 main valves off the trumpet. Remember, I drew that line before this way. This is the brachiocephalic. This one here is the left common carotid, and then this one here is the left subclavian artery. And this vessel, just look, this is the arch of the aorta, so we have number 14 was the aortic semilunar. Now we have the ascending aorta, the arch of the aorta, the descending aorta, and then this continues down through the thoracic region. It's called the thoracic aorta, and then it goes down into the abdomen, where you have the abdominal aorta. So this aorta has different branches. I'll say it again. So 14, the valve, is the aortic semilunar valve. Then we have the, let's call this number 15, ascending aorta. Number 16, the arch of the aorta. Then you have, let's say, 17, the descending aorta. And then in the thoracic region, let's say from here to here, the thoracic aorta, we'll put TH for thoracic aorta. And then below that, where the abdominal region is, right below the diaphragm, this is going to be the abdominal aorta. Abdominal aorta. Abdominal, sorry about that, aorta. Abdominal. And there's many branches off of that that are going to feed all the organs. Okay, so I would kind of like pause, and then when you do the playback, I would make sure that you can draw this out a few times. Okay, because if you can draw this out nice and slow and talk it out loud, you really own the concept of blood flow to the heart and then away from the heart. Okay, so here was the superior vena cava. Here's the inferior vena cava. That's what's bringing deoxygenated blood into that right atrium. And then this is the right ventricle. Here is a pulmonary artery that's going to pump deoxygenated blood into the lungs. Here's the pulmonary veins bringing oxygenated blood back to the left atrium. Here's the auricle of the left atrium. Auricle is just this little leaf-like flap. It's like a reservoir, and then down here is the left ventricle. Okay, and let me see. Let me take a pause here and see how everyone's doing. And then when I come back, I'm going to review this again. Actually, you know what? This is a little bit of a review because this just shows the chambers of the heart include the two atria and the two ventricles. And this is from the posterior part, right? Here's the anterior. So we know the two atriums are up top. We know the two ventricles are below. Here's from the posterior. We can see from the back, the left atrium, the right atrium, left ventricle, and right ventricle. But this is from the posterior. And that's why you can see the superior vena cava. It looks a little different from the back. And the inferior vena cava, both bringing blood into the right atrium. And then remember when I drew out the heart in the right atrium, I said there's one other structure called the coronary sinus, and that vein brings blood, deoxygenated blood, also into the right atrium. So there's 1, 2, 3 structures, 3 veins that bring deoxygenated blood into the right atrium. Okay. So the right atrium receives the blood from the superior and inferior vena cava and the coronary sinus. That's what I mentioned. So here's the superior vena cava, here's the inferior vena cava, and right here is the opening of the coronary sinus. You can see that little hole right there that I drew. Also notice, I want to point out, if you look at the left ventricle here, look at how thick the musculature is. Very thick. The reason why the left side is so thick in relationship to the right side is the left side has a much, much harder job to do. It's pumping blood to the entire body. The right side, simple job. It just has to pump blood into the lungs. Lungs aren't too far off from the heart. But this has to pump blood all the way up to the head, to the fingertips, to the abdominal organs, to the toes, everything. The right ventricle receives blood from the right atrium and it sends it to the lungs. So the right atrium sends blood to the right ventricle and then is going to send it up to the lungs. Pretty cool. Right here, you can see the valve now. Here's the tricuspid valve on the right side. Here's the bicuspid valve or the mitral valve on the left side. And there's a unique structure, very, very unique structure that's involved in maintaining the integrity of those valves. In the ventricles, we have these things called papillary muscles. They're like these little hills. They're called papillary muscles. You see it right here, papillary muscles. And from the papillary muscles, we have these cords, these tendinous cords. Interesting name. They're called chordae tendineae. Look at that. And these chordae tendineae are going from the papillary muscles, which are in the ventricles, and these cords or these tendons attach to the valves. And they put a little tension on them. And they need that tension because remember, when the ventricles contract, they're pushing upward. When the ventricles contract, they're pushing upwards. We don't want these valves to invert from all that pressure. We don't want either the tricuspid or bicuspid from all the pressure of blood pushing upward. We don't want those valves to invert back into the atriums. We don't want the pressure inverting them into the atriums. That would be bad. Okay. The left atrium receives the blood from the pulmonary veins. So here's the pulmonary veins, and it's going to bring the blood right here into the left atrium. Then it's going to come down here into the left ventricle. Through which valve? The mitral valve, aka bicuspid valve. The left ventricle receives the blood from the left atrium and sends blood all over the body. Because it's sending it all over the body, that's why if we look at a cross section and we look at the left ventricle, look at how thick that musculature is in relationship to the right ventricle. Big, big difference. You see that? Note that the wall of the left ventricle is much thicker than that of the right. Why? Now you know. It's got a much, much harder job to do. The valves of the heart open and close in response to the pressure changes. The right and left AV valves, you heard me say AV before. AV stands for atrioventricular valves. And then we have the semilunar valves. The atrioventricular valves, those were the valves here between the atrium and the ventricle, tricuspid and mitral. And then the semilunars are going to be the aortic and pulmonary semilunars. Okay, so here are the pulmonary semilunar. Here's the aortic semilunar valve. See, they're closed. Here's the bicuspid, closed. And here's the tricuspid, closed. This is lubbed up, lubbed up, lubbed up, lubbed up, lubbed up, lubbed up, lubbed up. When you're listening with a stethoscope, the closure of the AV valves are the first sound you hear. And then the semilunars close, that's the dup. You always hear the closure of the valves. You don't hear the opening of the valves, okay? So I put this here again for you just to see the flow one more time with the numbers. We can see, to review, superior vena cava, inferior vena cava, bringing blood into the right atrium. Then you also have the coronary sinus, the opening of the coronary sinus, bringing blood into the right atrium. The pressure builds up, you got gravity, and you even have some pectinate muscles. There's for the first time you're hearing that word. Pectinate muscles in the atrium contract, pushing blood through the tricuspid valve into the right ventricle. Pressure in the right ventricle builds and builds and builds and builds, and as it builds, it's going to push blood upward. And as it pushes it upward, tricuspid closes, but it shunts the blood in the direction of number 3 through the pulmonary semilunar into the pulmonary trunk, into the pulmonary arteries, into the lungs. Capillary exchange takes place, picks up oxygen, drives it into number 5, the pulmonary veins, drives the blood into the left atrium. Pressure builds and builds and builds. The pectinate muscles contract, plus gravity pushes blood through this valve here called the mitral, aka bicuspid valve, into the left ventricle. Pressure builds and builds and builds. The pressure forces the blood from inferior to superior, shutting the bicuspid, aka mitral valve, forcing blood through the aortic semilunar into the ascending aorta, into the arch of the aorta, down into the descending aorta, into the thoracic aorta, into the abdominal aorta. And then we have 1, 2, and 3 main arteries coming off the arch of the aorta: brachiocephalic artery, left common carotid artery, and number 3, the left subclavian artery. Good place to take our first break. Lots of information, very repetitious. When I come back, we'll talk about the layers of the heart.